Have you ever wondered why some supermarkets seems to be faster at checkout than others? Let's dive into this using Elixir GenServer. When you walk into a supermarket, normally what do? You grab your item, queue up at the cashier, pay, then leave. But how these supermarkets manages their queues can tell us a lot about concurrency. Let's compare three supermarkets: Supermarket X, Y, and Z. At Supermarket X, we have only one cashier and two customers at the queue. It takes about 2 minutes to serve each customer. So the total time taken by Supermarket X to serve the two customers will be 4 minutes. At Supermarket Y, we also have one cashier, but 10 customers are in line. With the same 2 minutes per customer, it takes Supermarket Y 20 minutes to serve everyone. But what if we had 10 cashiers for 10 customers, or 2 cashiers for 2 customers? In short, each customer with their own cashier. Enter into Supermarket Z. Each customer gets their own cashier. And guess what? Everyone is served within 2 minutes. This ability to handle multiple tasks simultaneously is what we call concurrency. It's like giving every customer at the supermarket their own cashier instead of waiting in a single line. Let's take this concept to an online store, the virtual equivalent of the supermarkets we have just discussed. In an online store, as a user, you are able to browse for the product and place a purchase, and it is at the checkout point where you finalize the purchase and pay for the product. For this demo, we shall simulate the checkout process for Supermarket X and Supermarket Y, where the task is handled sequentially. To process the checkout, there are information that is required from the user. This includes the customer information like the name, the email, and the address for shipping purposes. Then there's the payment information, which includes the payment mode that the user can select. For example, here I've only provided the phone number. That means that the user can pay through their mobile banking. For example, you can use M-Pesa, or you can use the credit card and the debit card payment modes. Then there's the order summary, which includes the item selected by the user and the total amount supposed to be paid. Our checkout logic will involve saving this information and processing the payment. Let's write some code and see how long it takes to complete the checkout one at a time. This is the checkout module where we are going to add our logic. What we need is to save the checkout details and also to process the payment. Let's define the function for that. I will call it process. This function will take the checkout detail. Inside this, we need to save the information, save the checkout information or checkout details, and also we need to process the payment. I'll define it as a private function, then name it as save checkout details. We need all the information that we get from the client side. This function will not actually perform the actual logic of getting the information and saving it into the database, but I will mimic that process. The saving of checkout details takes 1 second. Therefore, I will delay this process by 1 second or 1000 milliseconds, and assume that we have saved that information. If it's a successful saving, let's just display the information or IO put checkout details saved successfully. That's it for save checkout details. You can just put an underscore to this. Then we also need to process the payment. Same thing here. I'll just simulate the payment processing but not perform the actual payment. You can just name it as process payment or make payment. The make payment needs the amount. We are providing the phone number. Let's pass the phone number. To process this payment, the checkout application needs to make a request to a third-party API or a payment gateway that will process this payment, then returns back a status if it's successful or not. Let's say that this process takes 3 seconds for the payment to be processed. We can delay that process by 3 seconds using process sleep function. Same thing, we shall output and say payment processed successfully. I will interpolate the amount in here. Payment of amount from the phone number. Let's pass the phone number has been processed successfully. Yeah. So that's it for the logic. Now we need to invoke this function inside the process. We have the checkout details. Another thing, let's just add a status. We can pass a tuple of an atom and maybe say success. And this we can also say an atom of payment successful. Now we can invoke the private functions that we have just defined. I will use the with clause since I want to ensure that the transactions involved are all successful before we complete the checkout process. Let's define the with clause. The first function that I am invoking is the save checkout details. This returns a tuple of an atom and saved status. I'll just copy this. The params here is the checkout detail. The next function to invoke is the make payment. Once the saving of details is successful, we're going to invoke the make payment function. This is the make payment, which takes in the amount and the phone number. If both transactions are successful, we return an atom. Else, if we get an error, we just return that error. The else part is just for the future purpose. We are not handling the third path. The other thing before I forget, we need to retrieve the amount and the phone number that we are passing to the make payment function from the checkout details. This is how the checkout details will look like. I have passed this information under .ix.exs script file, which is defined under the root folder of the project. You will see how this script file will be of handy while we are testing. From the checkout details, we need the phone number and the total amount. To get this information for the phone number, that will be easier. We can do the checkout details and access the phone number. This is one way of accessing information from the map structure. The total amount, we need to go through the items, then through the total. So let's do that. Use the checkout details. First access the items. The items is also a map structure. Then you can access the total. That's it. Our checkout process logic is now completed, and you can see that it will take approximately 4 seconds for the checkout to be completed. Let's test the checkout process and verify that it's working as expected. Spin up the interactive shell using x-smix command. We have our .ix script file, which we added the checkout details. Just write checkout details if you added that file, and you'll see that you have that information. That's why I told you that this file will be of handy. So you don't have to be copying or writing these checkout details in our interactive shell each and every time that we need to use it. Let's call the checkout process function. That is checkout.process file, which takes in the checkout details. Checkout details saved successfully, that is after 1 second. Then after the 3 seconds, we are able to make the payment, and you can see we have an atom being returned, meaning that the checkout process is successful. This is a checkout process for one user. Assuming we are simulating Supermarket X, which was serving 2 customers, let's see how long that will take. But before we do that, let's make some enhancement to our code for the process function to be able to handle more than one checkout details from different users. I'm going ahead to add another function head with the same name. Process will take in the checkout details. To differentiate the 2 arguments, this will be checkout detail to mean 1 instead of details. Then since the 2 functions are similar, the only way to know which functions to call and not conflict, we need to add a guard clause. The checkout details in here will be a list, and this will take in a map. I will add a guard clause for that to pattern match if it is map. Also for this, I can add a guard clause when is list, because we have that. This is when it's map. For the lists, we shall iterate through the list. I will use each for this because the enum each returns an atom, and I don't need the return value or the output. I'm not doing anything with the output, just use enum each. We pass in the checkout details. That is a checkout detail without an S, and for the non-max function must have an end. we are iterating. In here, I will call process function and pass it the checkout detail. This function that I've invoked inside process will match with this one. That's it for this enhancement. Let's also make a change to our IX script file. Instead of checkout details being a map, let's pass it as a list and also pass more checkout details inside the list. For now, we're simulating supermarket X. Only need 2 checkout details. I will copy this and paste it. Maybe change the phone number for them to be different. This can be 11 and amount can be 1000. We have that. Let's go ahead and recompile the changes and process the checkout for the 2 customers. So just write recompile for it to pick up the changes. We have an error. Undefined variable checkout details in the checkout file line 15. Now it's taking checkout detail and not checkout details. Let's correct that. We can recompile again. Everything is now good. Let's see how the checkout details look like. It hasn't picked up the changes that we have made in the script file. I was expecting a list of maps and not a map. I think recompiling does not have an effect on this. Instead of recompiling, close the current interactive shell and reopen it. Let's confirm if the changes have been picked up. Now the checkout details is a list of maps. We can go ahead and call the checkout process and pass the checkout details. I had added a printout for the starting time and also for the ending time, to be aware at what time the checkout process started and at what time it ended. If we calculate the difference between the ending time and the starting time, you will see that it takes 8 seconds to process the checkout details for the 2 customers. Let's move to supermarket Y, which had 10 customers and 1 cashier. I have made some changes in the IX script file. Instead of increasing the whole checkout detail map structure when we need to increase the number of checkout details, I'm using the inner map function to create the checkout details by iterating through a range of numbers 1 to 10 and creating a checkout detail for each number. Then I'm passing the phone number as the number within the range and the total amount as the number within the range also. When we run these checkout details, it will give us a list of the checkout details for each number in the range. Let's confirm that first. This is a list of checkout detail for the number 1 to 10. That way it will make our work easier. Each time we want to increase the checkout details, we just make the changes within the range of numbers that we are passing in the inner map function. Now let's go ahead and see how long it takes to process the checkout information for the 10 customers. I'll clear this. Then I need to call the checkout process. You can see the starting time is 7:20. This is the starting time. You can see it's processing one at a time. We are at the 5th checkout. Let's just give it a few seconds to complete. It has completed and this is the end time that we are having. Let's get the difference between the end time and the starting time to see how long it took for the checkout to be completed for the 10 customers. I'll just replace this with the time we have, then copy the start time. It took 40 seconds to process for the 10 customers. As expected, serving the customers one at a time gets slower as the number of customers increases. When we served 1 customer, it took 4 seconds. When we served 2 customers, it took 8 seconds. When we increased the number of customers to 10, it took 40 seconds for the checkout process to be completed. That does not sound ideal at all. What if we could make this process to be faster? Stay tuned for part 2, where I will introduce concurrency to our checkout process. If you're curious how concurrency works in Elixir, you don't want to miss the next video. Feel free to drop your ideas or questions in the comments section below. Let's learn and build together.